Okay. Share my screen. Share. Slideshow. Okay. Are you folks seeing this? I got a thumbs up from Stephanie. Thanks, Stephanie. So welcome to week 5 on the writing and publishing online open course. Today we have kind of a fun topic. I think it's fun, which is figures and graphs, you know, and I've seen really good examples in reading. I've seen some not so good examples. Actually, I have a paper in review where like the table that is like the main crux of the whole paper is like 6 columns by like 40 on like the things that can like the soil characteristics that can interact with trees and their growth and health. It's just like a minefield trying to make sense of that. So people can lean on them a little too hard, you know. They can really be effective and like conveying a lot of information very concisely and effectively and drawing it out so people really get the core message of what you're trying to show. Or they can just be a mess and confuse more. And I've had a couple figures that and papers I'm working on right now that apparently have confused reviewers more than helped them. And so I'm guilty of that as well. So but sorry, this is a little blurry because I'm grabbing from the chapter, but the chapter had some really kind of cute and interesting examples. So, you know, a table in its essence is a way to like, hopefully just take like a whole paragraph full of numbers and comparisons and stuff and distill it down into one kind of concise figure, right? That's organized to make sense. But, you know, people can get a little table crazy, and I've seen some, you know, articles where there's like 14 tables in them, you know, and maybe not every single one of those warrants being pulled out in that regard. So this is an example where you can see here, there's really a lot of duplicate information, right? So you have the temperature is the same in both examples. The number of experimental units are the same. So those can be covered in the methods, right? So results are really, you need aeration, right? If you have aeration, then you have growth. If you have no air, there's no growing. So there's really no reason that needs to be its own figure. It's just essentially it's a sentence, right? There's more of that. So this one looks more impressive, right? You know, they're taking temperatures now. They're varying them, going from -50 Celsius to 100 Celsius. So like totally cold to boiling. And they're seeing how oak seedlings grow. Not a lot of stuff growing at -50, not a lot of stuff growing at 100. But, you know, they can see, they're showing that essentially in this whole big table, it's conveying one sentence, which is the oak seedlings grew at a temperature between 20 and 40 degrees Celsius, and there was no measurable growth beyond that range, right? So really a lot of zeros, that's your indication right there in the response column that this is a little overkill here. I love the funny footnotes in this one, you know. It's just authors getting bored, you know, and trying to, probably this joke's probably for them as much as anyone else. So another one, you know, I love pluses and minuses. I'm a sucker for these. I love it when you're doing like a lit review and you're trying to show trends in the data, and you know, like can we mute if we're having conversations in the background, folks? Thank you.
Or then if you grew a little bit more, that's here you can.
There we go. Thank you. So for this one, you know, you have a bunch of different, looks like bacteria, and they're growing them under anaerobic and aerobic conditions, and they're looking for like whether or not they grew in those conditions, right? And when it boils down to it, even though this is kind of cool to see the pluses and minuses, they were able, since the trends were so distinct, they really only had two things happening, right? And there was a group of bacteria that wanted aerobic conditions, and there was another group of bacteria that wanted anaerobic conditions, and you were able to write that same thing in one sentence. When you're doing a lit review, you might have, say you're trying to predict canopy coverage in the city. You could have maybe a dozen different factors that people try to use to predict that. And that's when that can be really helpful to see the pluses, minuses, and then like the third alternative you'll see is non-significant, or NS, as in there was no trend. To kind of make sense of everything that people have thrown at a given question. Table 16.4, what is that? Like it's just two data points. So I think tables can be effective in drawing people's attention to things, but that is probably a little bit blatant. Okay, so this is two different examples of arrangement. So these two figures, these tables had the exact same information. And I think I don't know what it is, but when I was an undergraduate, all of my tables for like Excel, when I was doing like undergraduate experiments and stuff like that, I would always go horizontal, right? And it just made intuitive sense to me to do it that way. And I've seen that in other undergraduates and early master's students that I'm mentoring. I don't know what it is. It just seems to make sense. That's how we read. But the more you work with data and the more you work in science and you work with like programs like R or SAS, the structure for data and that kind of analysis is always in columns, right? And so with training and time, scientists tend to like that vertical structure of their data. And so the first table, 16.6, is a little confusing to the reader, right? And it takes up more space. And the authors of this chapter talk about, limiting space because it's costly to publish, but I mean, everything's on a PDF now. And I don't feel bad for the publishers. They're making a lot of money. So don't worry about space so much, but I really worry about readability. And the 16.7 is a much more readable table. Things just kind of line up and you're able to kind of go across horizontally and look at each of those bacteria and see, or mycelium, that's fungus. So, look at the growth requirements, look at the color, what kind of antibiotic properties they have, and then the concentration. So. And then finally, this is what they hold up is like kind of the well-structured table. And I would agree. What I like about it is it shows it shows a lot of things. It shows means, which people always kind of gravitate towards, and we'll all show the means in our data, right? But it also shows some kind of measures of variability, both standard error and then confidence intervals, which are related to standard error. And if you are not putting standard errors and confidence intervals in your tables, there's a better than like a 1 in 2 chance, I'd say, that from my experience of when I've done that a reviewer is going to come back and ask you to do it. So you might as well just get it right off the bat and show that in there, which is kind of nice to see how variable things are. And then what I really like about this figure is they demonstrate that you can kind of group things together. So the hospitalizations, there's that horizontal bar that's kind of showing you that those two columns below it are related to hospitalizations, and then total charges, which is the monetary side of it, and those are all related, below it. So I think that is helpful to see, because often that's a very useful trick for grouping things like this together, and it's an organizational trick. The second chapter that we had was on figures. And just like you have tables that can kind of use a lot of space to show one sentence's worth of data, you can play that same trick with your figures. So in this case, there's a nice bar chart here, taking up a lot of space, and it's showing you essentially that of the 56 patients that were in the study, there was an average of hospitalization rate of 14 days and 6 acquired infections. So that doesn't need to be its own table. And it's also kind of like, it's weird to have those things in the same kind of bar chart because they kind of disparate bits of information in a way. And then finally, this is something that I think is a strength for figures is, and I have a few figures of my own that I'll show you from some studies where they've really helped me make sense of my data. Because often the temptation when you're doing this research is maybe you're like, maybe R or SAS, whatever you're using is a bit of a challenge, and you just want the code to compile, and you just want that ANOVA or that regression to, output the spit outs to see what the p-values are, and you may rush the whole visualization part of the analysis. And you can see here, there's the visualization can really kind of make sense of what you see. These two, the figure and the table show the exact same data. And one is a bunch of numbers and one is a bunch of data points plotted on a graph. And what you see here is there's an interaction with the figure that you probably might not pick up on if it's in table form. So for all of the treatments, negative cultures increase over time, right? But for the square, which is Mycobacterium tuberculosis, that has a much greater increase over time. Like the rate is increasing more. You have that kind of wedge shape, which is an interaction that, often when you get an interaction in your terms for ANOVA, plotting it will help you make sense of what's going on. So, and it also helps the reader, because you can have an interaction where there's a canceling effect, right? Where you over, like the things that were higher at the beginning are actually lower at the end, and lower were higher, and then that's a canceling effect. That is, it happens rarely, but it is it's very interesting, and it's something you want to pick up on. But I think the most common interaction that I've seen is like things getting farther away as they get bigger. Like think about weights in humans. Babies, they differ by a few pounds, right? Where like adult humans can differ by hundreds of pounds as they get bigger in size. And that happens quite a lot in biology, in trees, in plants, in fish, whatever. So, and with that, very short intro, but we have with us two very talented researchers. We have Jess Vogt, who's at the University of DePaul in Chicago. She runs, I love the name, the Loofah Lab, which is the lab for urban forestry in the Anthropocene. Great name. And she was an associate editor for urban forestry and urban greening, and an urban forestry like subject matter editor for forestry, right? Mm-hmm. Okay, and then Allyson Salisbury is affiliated with the Morton Arboretum, also in the Chicago area, but she is also doing a freelance like research and consulting kind of career option right now, which is very interesting for, I'm sure, a lot of you to see that as an option. Allyson works quite a bit in my lab on many different projects, and I just know from experience that Allyson is like an R wizard who can crank out some really nice figures. I used to spend a whole day writing code to make a beautiful figure, and I don't have the patience anymore. But Allyson, you do great stuff. So let's open it up to questions. I'm gonna have to get my questions up, so if you have anything you want to talk about, in like the next minutes or so, I'll dig those up, and then we can get going in the question and answer session. And folks, if you're in the class and you're taking credit, make sure that you're asking questions. I'm going to ask Elise to do a tally to see who's been doing their questions, and warn people if we haven't been getting them all in. Because I think, how many do we get? How many can they miss before the grades start getting affected, Elise? Like 3?
3.
Yep. So got to make sure that we bring those in. I want to make sure that everyone's still aware of that. So, okay. I will stop my share. I will bring up my questions and we'll get going.
Andrew, did you want us to start with the like icebreaker question?
Yeah, so the icebreaker question,
paper?
yeah, that's a
He
good
wants
one.
to
So
start with
I
that. Yeah.
remember that one. So the
Yeah.
icebreaker question is, what was your first writing experience? I'm going to ask this of everyone because I think it's really important. So what was your first writing experience like? Was it terrifying, exciting, crushing, what have you? And what was the biggest, like, what was the outcome and what was the big lesson that was learned from it? Thank you.
Yeah, I have a good one, I think, because my first journal article paper that I submitted, I never did the reviews and I never ended up publishing it. And to this day, I still get like, it's just available on the internet. Like we just put out a preprint and we're like, yeah, it's fine. But I wish that it was so good at the time. And like now the data is way too old. We would have to update it. You know, it's like 12 years old now, more than that. It's from 2009 and 10 is when we collected the data. So anyway, so we submitted to the Journal of or Arboriculture and Urban Forestry. And actually we didn't submit there first. We submitted, it was this paper examining indicators of and comparing urban forestry programs with community sustainability programs, which in like 2009 was like a really hot, like new thing, interesting thing to do. Now it's kind of old hat, part of why we could never publish it now without updates. But we had drawn on a lot of literature from this journal called the Environmental Impact Assessment Review journal, or environmental impact or something like that. And so we thought, hey, okay, one of the ways you figure out which journal to submit your article to is which journal have you cited a lot of papers in. But what we didn't take into account, and my advisor on the project at the time, we hadn't published yet in urban forestry. He was a traditional forester and was kind of still breaking in. And so he was like, sure, let's throw it there. Like, it should be okay, right? They should be able to find reviewers for it. And they could never find reviewers for it. So they sat on it for like 4 or 5 months before they gave us a desk reject, basically saying like, we can't find any reviewers, despite the fact that you suggested a bunch of reviewers and they never asked us. So that was really frustrating because we were like, but we could have given you more people.
Yeah.
So we were like, all right, fine. Let's just submit to Journal of Arboriculture and Urban Forestry. Like that is urban forestry stuff. It's not indicators, but that's probably where we should submit it at first. And it came back. I think Andrew, maybe you at the time would have been the like, is that your role?
No, I would, yeah, I was like behind the scenes, like helping move things around.
Basically, I think you would have had somebody like go get editors or go get reviewers and then turn it back and around and all that. So I'm not blaming it on you, but we had this like immensely long, lengthy, we got it felt like dozens of pages of comments. I think in retrospect, it was probably like 3 from 4 different reviewers. And it just, as a graduate student, a master's student at the time, I felt so overwhelmed. And I was already like doing some next projects. I was already thinking about PhD research. We had a big grant proposal that we were writing at the time. And they gave us this like very short, relatively short turnaround. I think not super short in the scheme of things, but it's like a month didn't seem like a lot at the time. And so we basically just said, like, we replied almost immediately and said, like, we can't do it in a month. We'll just submit it later. And I, to this day, really wish that somebody at some stage had told me, like, it's normal to get tons and tons of comments. Like, you don't have to modify them all, right? All the things we've already been hearing in the seminar for the last several weeks, because I think as a first-time scientific publisher, I was 23 years old at the time, lead authoring, I had no idea what I was doing. And, this was a little bit outside of my advisor's field of expertise. So he kind of wasn't, and he also was coming off of a lot of time being state forester. He was just getting back into research. And so he didn't quite have the modern kind of, he's like, I haven't published in a while because I've been state forester, right? So I don't really know. So we were just kind of figuring it out together, and no one kind of pushed us to say like, come on, you can do it. You can do it. You can do it. So that's my story, is that we just, we were like, we'll just stick it on our webpage. And, and to this day, people come up to, I still get people who say like, I found that paper. Why did you ever publish it? Like, where's the published, peer reviewed version? And I'm like, good question. Where is it?
I will maybe give it a shot again. Like, I know that journal was hurting for submissions for a while, so they're hungry.
Here's this 10-year-old paper.
Yeah.
Now we'll if we ever do anything with it officially, we'll do another survey, right? And then analyze change over time.
Because Rich Howard just published his master's research last year during COVID, his COVID vacation,
Yeah.
So that was like
that's
20.
biophysical work. The crappy thing about like trees, right? The biology of trees and kind of how they're impacted by construction or something. I think that's partially what it was, right?
It was like
because of the social science programming stuff.
yeah.
It's hard to justify that it's new and interesting to study community sustainability these days.
Well, very good. Yeah, a good lesson there is that it does look daunting when you first see it. We talked about taking the stiff drink or whatever, giving yourself time or printing it off and leaving it off on the side. But you don't have to bend to every single will, like you said, Jess. And sometimes people are pointing out the same stuff, so it's actually redundant, and you get to cross off like 3 things by making one change. Allyson, how about you?
Yeah, my first paper, it did get published. It was research from my master's thesis. I think my shortcoming with that paper, for starters, was I just jumped in and was like, oh, I'm just going to write a science paper. It's like a lab report, right? I had no idea what I was doing. Wrote the paper, submitted it to what I think was the appropriate journal for it. It was an engineering journal, and this was a paper of relevance to engineers. And first off, it took forever and a day to hear back about anything. And then when they did get back, they were like, well, we found one person to review it and they didn't like it. And their big criticism was like, this isn't a research project, this is a case study. And so rewrite it. And if you want, you can rewrite it and resubmit it to us as a case study, which was like a group of, or a type of paper you could submit to this particular journal. And so I was like, didn't feel great. The single reviewer was not favorable, and it was a critical review, and they were pretty blunt about it. And so, yeah, as your first time going through all that, it was a little rough. It felt like took me a while. That one I asked for, I got an extension to work on it longer, because they were like, you need more data. And I was like, well, sure, fine, I'll get you more data. I need more than 3 weeks, because I need it to rain several times. Get you more data. It's autumn. And I also brought in another, one of my committee members. I was like, so I'm having some trouble with this paper, and you know what? I realized I don't know what I'm doing. Do you think you could help? So I pulled in another committee member who was like an actual engineer. And so I think he was also able to help. Honestly, I kind of brought him in to lend a little credibility to the paper, but then also to kind of get his perspective on that. And it did get published. So it made it through. It's a nice little, what I think is kind of like an interesting little case study. But yeah, that it was not a very pleasant experience my first time publishing. But now, like, writing science papers is my job. And I don't hate it so much. So that's nice.
Yeah, it gets easier, with everything gets easier with time. And then you start making it harder for yourself by trying different journals and stuff like that. But yeah, no.
For analyses you're not super familiar with.
Yeah.
My first qualitative paper was the recent one that's been like, I'd published in a lot of kind of quantitative or mixed method space. And then I did a purely qualitative paper, and I was like, oh, okay, this is a different ballgame. Like, you found different reviewers. You found reviewers who do qualitative research full time. Okay, they're a lot smarter than I am. I guess I should. So that was another pretty bruising experience. That was actually my most recent publication experience. That was very as bruising as the first one, practically.
Yeah, and I've done, Allyson, so you're bringing in other people. I've had stuff where I got into a new area, and I thought I had a handle on it. And then I had, like Jess said, folks who really know the stuff look at it. And it's like I had to call in some help to get it through review. So that's another good strategy, is just know what your limitations are, which are often apparent when you see the review. and
have cheerleaders. And the key thing on my most recent bruising experience was calling a qualitative friend who saw me post on Facebook the frustrations. She knew a little bit about what I was studying, and she just calls me out of the blue and says, "You sound like you need a pep talk. I know nothing about this research, and talk me through this paper." And it was just a godsend. I was like the 45 minutes of her time that was like, you can do this, you know what you're doing, here's some strategies, here's how I deal with qualitative critiques, like,
Yeah.
so that like, so, now the next time I have that experience, I'm like preparing, like, okay, who can I call to just like vent about this to help me kind of talk through the context, who's familiar with this type of space that's at the edge of my expertise or something.
Yeah, no, and that is key. I have some collaborative friends who I can vent to, and they can help me get off the ledge of the paper where I'm gonna shred this thing, like. So cool. I do have the questions up now. I will start with my questions, and then we can move on to the student questions, and we can go from there. So here's one this one was something that I had a problem with when I first started writing. My advisor and I had different outlooks on a lot of things. And one of them was this. So common advice that we saw in our reading for this week and elsewhere is that tables and figures should be standalone. And that really makes sense in like the digital era, where sometimes it's easier to find figures than it is to find the full text, right? You just click on something that pops up. And I was actually looking for a paper, and I found a different site that actually had just all the figures pulled out on it, right? Which is kind of crazy. So you want them to be standalone so people can understand their context, right? This standalone is made possible by the table titles or the figure captions. How detailed do you have to make these things? What do you put in yours to kind of give it that context? What's too much information? Because my advisor liked little novellas when we did ours. So
I will say what I don't put in captions is like the summary of like the point. I don't write out like the point of the table. So in the text, I will say, as table 1 shows, survival was much lower in the 30-year-old group of trees compared to the 10-year-old group of trees, right? Like whatever the point of the table is, that I will write out in the text. I don't put that into the caption, but I feel like I have like my lead sentence of, table 1 shows, percent survival by planting group age, whatever. And then anything like, if there's any abbreviations, those get spelled out. If there are, if it's a figure and there's different symbols, or there's different, abbreviations, symbols,
Color scheme.
If there's like whatever the confidence interval is based on, those are things I will add into the caption, so that in my mind, it's kind of like the interpretation can be done standalone. If you want to add to that, Jess.
Yeah, I think I was going to actually start the same way you did with like what you don't put in. You don't put in the what it means, right? I think in a lot of what I teach students how to write when they're doing lab reports, or they're summarizing the results of a mini survey, and they have an excellent figure that they've used pivot tables in Excel to kind of come up with. They want to put out that, like, but you put in the caption like, oh, this means that people who did X also did Y, which might mean Z thing, right? Like, don't put in their interpretation, like the like what it means substantively, right? You want to stay away from substantive explanations and just put in kind of what you're looking at, the dry, relatively dry, objective things.
Either of you put in like geographic context, like this is from the city of Indianapolis, or this is, like that kind of stuff, or what I'm saying, or like time frame?
Yeah,
I don't, because I almost always put a study site in the title of the paper.
Okay.
right? So, because I agree with you, Andrew, you know, you're looking at like a journal website, even like Science Direct or something, right? Science Direct, the unpaywalled version of Science Direct has the abstract, and then along that right hand or left hand side there, you can click right on and get the full, you know, not usually full resolution versions of the figures or tables from the text. And so if somebody's not just looking for an unpaywalled version of something, that is what they're looking at. So I'm assuming that that the title and the abstract has enough information about the study context that people don't need to like, that people truly aren't looking only at the figure, that they're at least looking at the figure and the title and abstract.
Very nice. I like that.
That
was
seems
thinking-
reasonable to me.
Yeah, because I mean that was the big thing that I mean, all my papers from like my graduate studies have like Urbana, Illinois, and maybe coordinates in there, something like that. And it was yeah, they don't have it now, but cool. Elise, are there any questions that you've seen that are really sticking out in your mind?
Yeah, I think several of us would like to know, what are your preferred tools for setting up tables and graphs?
Very nice.
So I am a huge Excel fan, and I think that's probably controversial, especially as, you know, R becomes more and more popular. But I really like Excel as a first pass tool. And this might be related to the fact that I do teach and interact with mostly undergraduate students who do take an R class, but it's like usually, you know, very senior in their undergraduate career, are they taking the R class finally. So I teach Excel, and I use Excel as like a first tool for data visualization, in part because I'm working with people where they're at such a learning curve in R that like to produce a really nice figure in R that you can dump into a publication or even just a class report takes so much effort and coding experience for them that they just don't have yet, that it's often easier to kind of do the first look for some things, not all things, right? You know, because some things in Excel are tremendously difficult. But you kind of the first look at like distributions of variables, right? Like I do a lot of, you know, survey data, or even just understand, you know, like producing a really simple like histogram, right?
Mhm.
Like you can use pivot tables to actually produce a pretty cool histogram and alter the bin size and stuff and kind of see it live in a way that's pretty helpful. So I like Excel as a first pass to then figure out what you might want to do as the more advanced analysis in a statistical software.
Do you feel
I can
like
talk more about other softwares, but I'll stop there for now.
do you feel like you can get publication worthy figures from Excel? I mean, consider it's like a first pass. Do you actually will you take your final tables and figures from Excel and publish them?
Yes and no. And here's where I have been a long time devotee to InDesign
Mhm.
as a tool for, so you take the simple version in Excel and you copy and paste it into or, you know, save it as a PNG file, and then you open it in InDesign where you can kind of more flexibly move around the components of the figure, right? Like you can put the legend exactly where you want it to make it kind of as tight, or you can say you have two, Excel doesn't do a great job of like, so I deal with a lot of Likert data where you have agree to disagree, strongly agree to strongly disagree, right? And you can produce these really nice stacked horizontal bar graphs in Excel. You can't very easily do clusters of those. Like, let's say you want to compare the distribution of agree, disagree in one study population to agree, disagree in another study population. And you want to do that on like 7 survey measures, like 7 things together. You just create each one separately and then like offset and nest them in Excel or in InDesign. So I do some things like that because in part because again, like it's simple to teach. I'm at a place in my own research where like I don't have tons of time oftentimes to devote to like creating the figures myself in R, or I use Stata a lot too. And so if I'm having students do it, it's easier to kind of just say to describe to them and they can use Excel to do that as opposed to something else. But yeah, usually I go into InDesign to do the final kind of moving around.
Yeah.
And InDesign is great because then like the file comes in as a live file extension. So like, let's say you realize that like you hadn't, you hadn't, there was a value in your data that was like an error, or like you needed to do a final cleaning thing or something, you need to change something in your data, then the Excel, graph will update, of course, right? If you then resave that graph as the same file name, InDesign will automatically like load in the new file
cool.
the next time you use it, which is like the next best thing to like truly automated code
Mhm.
in R, which is obviously the gold standard for any of these figure creations.
Yeah, Rich Hauer, who I work with quite a bit with, is an Excel master as well. And he actually has like templates set up where he makes a lot of the same figures that he always makes. And the formatting's right there. And they look great. Like they do. It's come a long way. I think Excel has a reputation that precedes it sometimes, but when I was at Illinois, we taught an undergraduate level stats class in Excel, and you can do pretty much everything now.
Just change the default colors because it really does look dumb in publications when I see like the Microsoft Office color scheme or something like that. I'm just like, well, change the font a little bit. Just don't make it look like you created it in Excel.
Yeah. Allyson, what do you use for your figures?
So I do agree. I think Excel is great for just learning how to handle data and learning how to do basic visualizations. I think it's a great tool for that. That being said, I do almost all of my graphing work exclusively in R, probably because maybe I'm just a glutton for punishment at this point. It's usually my job and it's free since I'm not a professor. I like free things, or I like free software. So yeah, I use R for a lot, just about everything. And that's just taken a lot of time and practice to develop that workflow and to kind of just similar to Rich, actually, I kind of have sort of templates, I guess, at this point where I work with similar types of data for different projects. So I can like go back to code I wrote for one project, copy it, and then tweak it for a new set of data to produce similar style graphs. It has definitely taken several years to get to a point where I feel very comfortable and confident making all sorts of different graphs in R. But the advantages are that it can be very flexible and in building, I think, more complex graphs that show multiple layers of data. And then another tricky thing that I think is maybe sometimes it's an issue I've seen colleagues run into when making graphs in Excel for publication is that depending on your journal, some journals have requirements for the resolution of your figure, right? So usually a minimum 300 DPI is pretty common. And I think Excel as well as PowerPoint can sometimes be really can't give you that resolution. And just, I don't know, maybe you want to comment?
Yeah, that has been the constant struggle. I mean, that's why a lot of times I'm going into InDesign, right? Yeah. Like I'm importing something, and what I'm exporting from Excel is often like the simplest line. Like I make it enormous in Excel, like font size gigantic, and it looks stupid on the screen because then when I put it into InDesign, I can shrink it down to a size and still retain kind of the ability to the fonts and all that stuff. But yeah, I mean, I will agree also, like I should say, I do use Stata a lot. So I came of age and in not necessarily pre-R, but just in a program that was not using R at the time. And we were using a lot of Stata. I was surrounded by a lot of econometricians using SAS and Stata. So I actually learned SAS first, then Stata. And I just haven't myself made though I've worked with a lot of colleagues who've done R stuff, and I know R well enough to like mess around with it with students. And I use the R to Stata handbook or Stata to R handbook quite frequently. But so I do a lot of the graphic stuff in Stata too, because of the export feature, right?
Sure.
So you can export exactly at the resolution that you need more easily.
Yeah, and I just want to, for the folks that are using R, I want to show this book. Can you see my Yeah, so the R graphics cookbook is amazing. And I don't know if this is going to give me a virus, but I think you can open this and we'll find out. How's it going? Anyways, well, there are free versions of the book as a PDF that my students have found. It's a great book, and it's really just like, it tells you how to do like the basics, and then it's organized on how to add the different things like adjusting titles and adjusting axes, and it's very intuitively laid out. And you don't have to read the whole thing. You can just kind of like skip around, and it's really intuitive. So look for the free version.
Mhm.
Oh, and that, to build on Allyson said, she has like this template code, right? Like whatever your process is, so I have my students kind of write out the kind of, okay, do this, this, and this. Like we do a lot of pivot table based stuff. And so in that, like the template is get the pivot table chart looking exactly how you want it, then swap in all the different variables you want as you copy the sheet, right? Like the same thing applies in R or Stata, right? Like you have this kind of set of template code with these types of variables, and then you copy that code and you keep it somewhere, and you label it clearly, like, okay, this is how, if you're trying to look at a set of Likert data and a set on 3 different categories, right? Like I kind of keep things where I'm like, all right, so I have 3 different groups that I want to compare Likert data for. Here's the code for how I produce that graph in Stata.
Very cool. Yeah, I think you hit on something too, Jess, that when you're in grad school, your university will have like a cheap student version of SigmaPlot or Stata, or in Illinois it was Origin Lab, because they want you to get hooked on that. And then the moment you leave, you're paying the full price.
I know, now I'm paying $200 a year, which every once in a while when my department has extra money, I get them to cover it, but.
Yeah, so they're really powerful, but if the moment you move to a different institution, they're probably gonna have a different deal worked out with a different program.
Yeah, no, but coming from somebody who does not use R, learn R. It's free.
And I use Origin Lab now. I was using R and I'm like, it's so much faster to use it. And so I pay $500 a year for it, and it kills me every time. I have a bunch of questions left over, but I know you have examples of figures, and I don't want to lose that opportunity because this is about images, right? So why don't we,
or if there's more student questions, maybe.
Yeah, we can do that too. So
more, I don't know.
if there's at least want to look for some more student questions, and then Jess or Allyson, if you want to bring up a figure or so.
I have a favorite figure.
Okay.
So I don't know what this might have been one of the ones you emailed me about, Andrew.
Okay.
Yeah, it'd be great to see what you all have put together. And I will say that there are a couple questions related to what do you do with large data sets? Do you chop them up into several small things? Do you cut certain stuff? How do you organize it? Like, sometimes stuff will span several pages. So just kind of addressing that.
Never delete
question.
Variables, never delete observations. You can subset in the code, but never delete them from the original data set. That's my short answer to that question, is don't chop. Don't. No, use if commands. They're your friends. I have this is one of my kind of favorite figures. So this is from a paper where we had a growth model and a survival model. And this is like, I think kind of a fairly typical way of, although everybody has slightly different way of presenting regression results, where you have like a big list of variables here. We had divided them into kind of components to organize things a little bit more clearly. We have, one model without interaction variables here, interaction effects, and then we have one model with interaction effects, and then we have like a reduced final model based on, I forget which method we used to determine which this was 7 years ago, so forgive me for not remembering every detail of the analysis. But so we have this big old honky looking table with all the results, 3 decimal places, standard errors. Like, it's just like, okay, that's a lot. Same thing here. This was the one from survival. Again, a lot. Like when you're, we recognize that it's best practice to kind of put all your stuff there. You got to look at it. We did some things like, well, we bolded things that were significant. Okay. That's nice. But when we were putting this paper together, we put some, we have asterisks here for 3 different significant levels, right? Like we definitely, when we looked at when we were putting together these tables, we're like, this is so hard to understand and talk about. And especially when we started presenting this work at conferences, like we were presenting this work at conferences frequently as we were developing the final versions of the paper. And we just realized we got to have a better way to present regression results. They got to be visual. Like this is not helpful, especially when we were talking to practitioners, right? I think in urban forestry, a lot of our work has, or all of our work has practical implications. And a lot of times we're presenting that work, not just to other scientists, but to people who want to be able to understand how to plant and care for trees better, right? Or prune trees better, or whatever it is. And so we did a couple things for this one. So this model was it's a probit model, which is like a form of logistic regression where we are predicting survival. So zeros or ones, right, are a dependent variable there. So you get the results you get of a probit model are what's called odds ratios. And odds ratios are kind of these interesting things, right? It's the odds of, it's like how much more likely a tree in this case is to survive based on the presence or absence for dummy variables or for like a unit increase in the independent variable here, right? So we put together this figure here that shows positive significant effects are these dark filled circles, right? So you can see the error bars there do not intersect with the 1, right? The 1 means no change, like no change in the likelihood of survival. And then less than 1 means, a negative impact effect. So we put the 90% confidence intervals on here. And, you can kind of easily see here, like, so there is, what we're getting at here is kind of the difference between, substantive effects, right, that are kind of meaningful and like not just significant, but may have a big impact. And you'll see like, some really, on the resolution of this graph, right, like this looks like it's a significant effect, it's negative, but it's quite small, right? It's right on that odds ratio there. So basically this is what tells us is like, okay, so, percent impervious surface is like obviously a variable that exists as a continuous variable from 0% to 100%, right? And for every single increase in percentages there, we get a relatively small decrease in survival, right? But it's not, one of the like major variables here, unlike, for instance, fall planting, right? Trees that are planted in fall are almost twice as likely here to survive with an odds ratio of 2 as those that aren't here. And we see a wide confidence interval, but it's far away from 0. So this was one of the ways we kind of summarized survival results in this particular paper. And the way we created this figure was a basic survival coefficients here. There we go. So I actually, you can see, did the odds ratio here in Excel and then took this graph and like, because this is impossible to read, took this graph, put it into InDesign, turned it up, on its head, added some nice labels along the side there, added the dashed line so that it's kind of more interpretable. But all we're doing here is just using kind of the actual odds ratios that were produced in that table in this.
Yeah, I love that figure.
Right.
I think we brutally steal that design like at least 2 or 3 times.
Yeah, it's an intuitive way. We especially found it like when we were talking with practitioners, they were like, what in God's name are odds ratios here? Like, but then once you kind of start understanding, it's like 1 is like no more likelihood of surviving as not, and less than 1 is less likelihood of surviving. And so once you walk through it, like this makes sense. But then the last figure I'll just really quickly show here is then we took that information also when we were like, okay, well, we're actually interested in like comparing those variables that are significant for survival models, yeah, but also for these growth models that we had run, which was a more traditional growth regression, right? That's a logistic, or not a logistic regression, just a generalized linear model with a continuous dependent variable. And so we put in this kind of color scheme here where we can say, okay, so the solid, the darker the color, the more significant, the lighter the color, the less significant, and the patterns are positive and the solids are negative here. So you can kind of quickly at a glance say like, oh, okay, here, there's a bunch of things here that are significant in the survival model, but don't necessarily impact growth. So we could kind of enable, and this is another graph that we presented, in pieces. When you put it on a PowerPoint slide, you kind of chunk it up and say like, all right, let's just look at the tree factors and the biophysical factors. Okay, now let's look at the community and institution factors. And so
Very
on.
nice.
So.
No, I like that organization quite a bit. So.
Can I ask a follow-up for that? Do you remember if you got comments back on those different visuals?
I would have to go look. I don't remember getting tons of pushback either way. I think I mostly remember getting the positive feedback when we do it in presentations of practitioners where they're like, oh, okay, like this makes more sense. Like the darker, more important, got it. Right. But yeah, I'd have to look and see what reviewers said.
Yeah, that only because I asked partially because there was at least one question about, well, there were two that kind of relate to, how nice do your graphics really need to be? How nice does the graph need to be accepted? Especially when, like, if you had submitted maybe the version from Excel instead of making it fancier in, in InDesign and that kind of thing.
No, I don't submit, like I submit exactly what I want the figure to look like. Because like the data and interpretation, and for me, the presentation matters. And also like, you want your reviewers to like really, like you want your reviewers to love your figures. Like if they hate your figures, you're going to hear all about it and you don't really want to deal with that.
Yeah, I think some advice that Rich has always told me when we submit stuff together is like, you want the Word document you send to look almost as good as like a published paper, like no tables cut off, or like there's half the table on one page, half the table on the other, good looking figures, because that's part of the overall impression. And if it looks gross when they're reviewing it, they've already been biased the wrong way.
Yeah. Oh, and if you're allowed, some journals don't allow this, but if you're allowed, put those tables and figures right in the text.
Yes.
Like, don't make your reviewers scroll through 40 pages of double space nonsense to get to the end, unless the journal requires it, in which case.
Yeah, it's on them. It's not on you, know. But yeah, I agree. Don't. I hate that. It's like, what is this from? So I'm gonna interrupt just for a second because I want to show something, because you had it in your figure, and I think this is a very important thing. So Jess showed confidence error bars in her work, and I think those are awesome. I love confidence error bars. And there's a nice short little article called Error Bars in Experimental Biology, and it's showing just how standard error, confidence error bars, and standard deviation bars kind of behave with different sample sizes, and they're like, the interpretation for a standard error bar really changes with sample size, right? So if you have n equals 3, like your gap for a standard error bar, like there's like no real good cutoff to like kind of gauge statistical significance with a standard error bar. It's kind of like it's far enough away, right? If you're using a confidence error bar, it's a relationship either. So if it's like a small sample, like 3, if the confidence error bar, like if this is kind of intersecting with the actual mean, you have a p-value of 0.05, right? And then when you get to anything above 10, it's half that distance is like your basis for statistical significance. So I love confidence error bars. They're not that much harder to create because there's a relationship between a standard error and a confidence interval. I'm murdering my words right now. Sorry. But I think, and what you have to do, and what Jess did in her figure, was explain what that error bar is, right? Because if you just have an error bar and you don't give the context, people don't know if it's standard deviation, standard error, or confidence interval. And then, like, your methods will tell what your sample size is, but you can also put that in the figure as well. So, and I'm done with that. That's my little diversion. I wanted to make sure I got that in this time. I love that paper. I'll link to it in the notes.
Allison, do you have a favorite figure? Since you're so R oriented, I'd love to like.
I was going through my papers. I don't know if I have a favorite
figure.
ever. I will say I was going through my papers, and I'll share my screen really quick. I was thinking about the question regarding like how do you handle a lot of data. So this is a paper, and I guess I will respond with a question like, what do you qualify as a lot of data? Because a lot of data means different things to different people. But I don't know if this was maybe the type of situation perhaps people were asking about. So this was a study about photosynthesis of trees growing in soil that was contaminated with heavy metals. So we were contrasting the photosynthesis of trees in what we classify as a low metal site versus a high metal site. And this chart, we were looking at the relationship between temperature, or we were looking to see if leaf temperature relationships varied between our high and our low metal sites. That did not. But if you're familiar with photosynthesis work, we look at a lot of different variables sort of in tandem. So that's what every panel is, a different variable, photosynthesis variable. We have the carboxylation rate, the electron transfer rate, et cetera, et cetera, et cetera. So it's all the same kind of set of measurements, but looking at different responses, or we have different response variables. And so I'm a big fan of paneling data, or you can look for the word panel or the word facet.
Mm-hmm.
Some R programs call these facets, FACET, as a way to sort of organize data. And that's something I really love about R, because I'm often working with multivariate data, and paneling is a great way to show that. So there's a few layers here. We have our initial response variable, which is, our predictor variable, leaf temperature. So that's consistent across all of the panels. And then we have different response variables. So that's another kind of layer that breaks our panels apart. And then I color coded each of the data points with the low. I think the closed circle is low metal, open circle is high metal. And then I show the regression results. And on this set of panels, I got kind of fancy because only 5 of our 6 variables had a significant linear relationship. Our transpiration rate did not have a significant linear regression associated with it. So that's why this panel doesn't have a line going through it. So yeah, there's a lot of information crammed on here, but I kind of what I like about this figure is that you can kind of quickly look at it and see from the regression lines, okay, positive relationship, positive relationship, positive relationship, negative, negative, nothing. Okay. But if you're curious and want to dive in a little more carefully, the actual data points are also shown in the
Data
graphs.
points, and then your model.
And then the
your
model
squared.
results
Yeah.
as well are
Yeah.
here. So this
These
is
are
very much a
cool.
cram it all in.
Yeah, these are the
approach.
types of figures that I think first time readers of scientific papers, like whenever I'm reading scientific papers with students or people who just are still at that early stage of familiarity, they gloss over figures like this, not quite realizing the immense depth of information. And these are the ones, like, I love them as figures like this. I love seeing these in papers. I've made a couple, when we've done some other logistic regression results. You can do some cool things with that too, to kind of show odds ratios change, interaction effects. But if you're looking at a figure like this as a reader, right, one of the things, the cool tricks is just like write a sentence in the margins of each thing, or a couple words, a phrase of like what you're seeing here, right? And it's a good figure if you can do that, like if there's enough information in the caption, right? And as the producer of this figure, then like before you would submit it for journal publication, or before you'd approach your advisor with this set of panels, you want to do that. You want to have that interpretation, and like, what's the sentence of explanation behind this? Because it's such a cool way, like paneling to show multivariate data like this is like really, really helpful.
Yeah.
Modern
Another quick point I want to make, as I was remembering looking over this, that I guess one of my just general philosophies when it comes to graphing, and I've adopted this from other people who I think are excellent visual communicators, but I'm a big believer in, whenever possible, like just showing your raw data as within reason. Some situations it's not always convenient to see that, but I think it's really important to just be able to be transparent and say, like, here's what I measured. Sometimes it looks like crap. Sometimes it doesn't. Like this E figure, I think Elise had brought up a question earlier in our discussions about, like, when do you show non-significant data? Well, in this case, like, this is the non-significant data. You can kind of squint at it and be like, there's like almost a negative trend, but I see where it isn't significant. But again, in the broader context of the study, it was important to point out that, transpiration, we didn't see a difference. So that's my kind of one of the philosophies I try to adhere to when I'm making figures.
Very cool.
Within reason, of course.
And you show confidence error, or like error bands, sorry.
Mm-hmm.
So you're showing, that, which is nice. That's often something that reviewers will pick up on.
Mm-hmm.
One question I have is, this is a lot of stuff on the same scale. Sometimes I'll facet my graphs just to get around like figure limitations. What do you do if they were on completely different scales?
Do you mean like if
there was no axis in common, like you had an x-axis in common for all
Yeah,
those
which
figures.
was temperature. How do you go for aesthetic, or do you try to, sometimes you just have different scales for things and you're kind of grouping them together. Do you keep the X?
Oh, you know what? I have a figure to show your issue. If you give me, talk about something else really quick. Let me pull that up.
Cool. I'll have a quick question that I'll ask Jess while you're looking that up. So Edgar asked, what do you think about ANOVA tables included in papers? And what do you think about that?
I don't know that I have a strict opinion, in part because I don't run tons of ANOVAs.
Mm-hmm.
They're just not, I don't know why. I tend to, I think because I'm dealing with a lot of like,
I think because we're not
categorical
experimental
variables.
people.
Yeah, like
Right.
I have like a lot of like I have both things. Like I do like chi-squared and Fisher tests, right?
Mhm.
Like when I'm showing kind of two variables. I typically don't have a single like dependent continuous variable. My dependent variable a lot of times is like survival, right? And like that's not an ANOVA analysis. So I guess they're just not what I do. So I don't have a good answer.
Yeah. I think when you have, I think I like putting I like to put statistical data into tables when I have multiple models. So say if you just ran like one ANOVA, you can probably mush all of those results into a single sentence. But if you have, yeah, I also don't use these, so I don't have a great example off the top of my head, but say you ran an ANOVA for like species A and species B and species C and species D, and you're interested in, and you want the reader to compare the results among the different ANOVAs that you ran, I think in those situations, putting them in a table is more helpful. If that's,
Yeah.
that's
I mean, I
my
think you hit on a good general point there, Allison, that's like, what do you want? And this actually partially answers Andrew's question too about paneling, right? Like paneling makes sense if you want somebody to look at the figure as a whole. Like you want them, you know, maybe it is 4 different scatter plots of 4 different, like there's no single Y or X axis in common there, right? Like, and that's fine as long as like you want your reader to look at all of them at the same time, right? Like, you know, don't do it, you know, you kind of said it in Jess to get around figure like limits, right? If you
I wasn't
want to
kidding.
have 5 figures or something,
sure.
you know, and definitely sometimes like there's an occasion where you kind of do like you need to squeeze it through. But also like, you know, a lot of times journals will say max 5 figures. And like, if you have 6, like no one's actually checking. Like you can just upload it and the system will deal with it. So I like the same, I feel the same about like word limits. I'm like, you know, oh, it says there's a 5,000 word limit. Here's my 8,000 word paper and no one cares.
I know.
You know,
Yeah.
because I do qualitative work and I'm submitting to places where they're like not super used to qualitative work. And I'm like, well, qualitative work is longer. Like 8,000 words is short for qualitative paper. Those are usually 12 or 13,000. So I don't know. So I think like I'm a fan of like knowing the rules and then like breaking them.
Yeah, no, I usually start out following the rules, but then by the end of the review, I've broken them, you know? And so to the question about, I think that was a good point, is that if it's like one ANOVA table, that's just one sentence, right? But, you know, multiple ones might be worth putting in a figure. Then the other, I will say that there are some norms, like I've seen in ecology papers where they want you to put maybe that table in there. Or an F statistic, right?
I guess maybe to build on Andrew's comment, I think I would, one of the first things not the first thing, somewhere in my writing process, you know, when we figure out like, okay, here's the journal we want to submit to, I will go in that journal and I will try to find other papers that use similar statistic techniques or have similar kind of sets of data that we're going to present or that we're writing about. And I will look for, okay, like how are they presenting their statistics data? Is it getting presented in a table? How's their table formatted? Are they just writing text? Like how much statistical detail is like acceptable or required for that journal? And that's maybe that's my primary approach, is just like, well, what's the norm for this particular journal, and then I will try to follow along with that, because sometimes in some disciplines they really value having all the gory details of your stats analysis. Other places, much less important, or that's info you can like shove in a supplementary file in case somebody really wants to see. So maybe that's my very vague answer to that question.
I'm a fan of including, I think for that paper that I showed, you know, we had like model G1 and G2 or something, right? Our 2 different growth models. I think this was the paper where we also had a couple more versions of models in the supplementary text, in part because we were dealing with so many variables, right? And there's so many different approaches you can take to regression, right? You can take the kind of kitchen sink approach, chuck all the data you got in and let the computer spit out which is the like best model based on all sorts of numerical criteria. We were taking we did a little bit of that, but we also kind of were intentional on the front end about what data we gathered, right? And we were part of our paper was articulating this like comprehensive social ecological approach where we want these 4 separate categories of variables and we think all of them are important, and here are some kind of choice selections from each. So that's why we had to show the full model, because they have theoretical justification for it. So I think in general, kind of when you're thinking about, this goes back to the like dealing with a lot of data, right? And maybe this is a lot of variables, less than like a lot of data, but we had this, we had the N to support putting in lots of variables in our regression models. And that's another kind of key characteristic that you have to make sure that you can handle your degrees of freedom can handle what you're throwing at it. Because statistics software will often, spit out results regardless of whether or not they're valid, right? So, kind of thinking through all of that and then just being kind of careful and measured and saying like, okay, if there is kind of some waffling about what model I include or what results I include in my text versus show in the appendix, just to kind of, because sometimes you are running extra models to satisfy reviewers too. And so you might have, the what would be like the 5th or 6th table in a paper, and you're like, this is just too much. Reviewers say it's too much, but the reviewers want to see it. Dump it in a supplementary online or an appendix so that you can kind of say, we did it, and then you don't have to do that. Like what I hate, and I've done this a couple times, is the like results not shown thing, because I think like using that language in like something wasn't significant, results not shown, occasionally you can get away with doing that, but like the paper on the internet is free, so unless the journal you're working with has severe limitations, just say results appendix 1 or whatever it's called, supplementary table 3, just put it in there. Like you probably have it. And that's where you really don't need to be fussy about the formatting, right? Of the supplementary online material, just dump in something as long as it's readable, right? But just dump it into a Word document and upload it and like call it a day, right? So you have it there. It's there if people want it. You have covered your bases, telling people, I have this, I'm not crazy. I did run this analysis, even though I'm not showing results in my actual paper because of space, because it's not the core focus of my research question, because reviewers wanted it, but it's not, for whatever reason. So
this is kind of reminds me of a question I saw that Andrew came up with about determining what stuff is like the research team's eyes only versus what goes out into the world.
Oh yeah, that's a good question. Not that's to my own corner.
Good question.
No, it's one that I had, like I think everyone has to navigate. You make a lot of figures to look at things and to figure things out, and then when you're done with your model, you look at the residual plots, or if you're working in SAS or R, to see if you're meeting your assumptions. What of that doesn't make it in the paper probably is a good question.
Oh, I have so many figures that, well, Andrew, you've seen. My approach, so I have so many figures that don't make it into the paper. For me, like making figures is like a key part of just assessing and evaluating my data. That starts off with like, first, I want to look through my data to see if there are any wonky numbers or anything that got spelled wrong. Looking for kind of basic relationships between variables. So for me, data analysis is a very iterative process, and figures are kind of key all along the way. And those figures look like garbage, but they're enough that I can, again, get a quick overview of like, okay, everything's looking reasonable, or like, oh crap, like these 2 variables are completely correlated with each other, and that's deeply inconvenient for my stats method. Crap, back to the drawing board. So there's it's a very iterative process as I'm trying out different data analyses, looking at the condition of the data, and then eventually, and then sharing that with the team as well. Andrew's gotten several very long documents from me of like, here's all these graphs I've made of our results. Here they all are. And again, that's me trying to be transparent and just say, we're looking at everything. Okay, here's the story I think the data's telling. Do you agree? And then once we sort of identify, we go back to when it's time to start writing the paper, I go back to the questions that originally drove the study and say, okay, what are the key questions we're trying to answer? What are we think the answers are? And then how can we visually tell that story? A lot of my graphs actually start off as like sketches on paper, because I'm a visual person, and it's actually really helpful to see like, okay, I know I want a graph that looks like has these 6 panels and it's going to be bars and whatever. And then I can go into Excel, or then I can go into R and then create them. I heard kind of interesting advice. I don't know if I necessarily follow it all the time, but I've heard it suggested that your paper should have like kind of 3 key figures that tell the story of your study or your experiment or your results. Anyways, that's kind of my approach, is sort of making lots and lots of figures and options that are ugly, and then saying, okay, what is it that I really want the reader to know, and what's the most effective way to visually communicate that? So yeah.
Yeah, I will add to that just from the like sharing with practitioners results. So I often do either it's survey research, or my primary methods are like interviews, surveys of people, or tree inventories, right? And when I'm doing surveys, especially, or tree inventories, I'm often doing them with a particular like stakeholder organization in mind who really cares about the results of my tree inventory and wants to see like every single variable summarized, like like the distribution of the pie chart of species, the DBH histogram, the height histogram. Like, so I have all of these. So I start kind of think about, and I often task students with, I'm like, all right, you're basically creating like either it's a Word doc or like dump them all into PowerPoint slides, all the single variables, like a summary, put the best format for showing each variable. Like think really carefully, like, is it a pie chart for this particular variable, or should it be a bar chart, or should it just be a table, right? Like sometimes species tables are actually better because you get a lot more percentage. If you have too many species, a pie chart doesn't become very useful. And, so think through what's the best format of showing each data, dump that into a PowerPoint or Word document so that we have it to share with our stakeholder, or to use in presentations where, it's nice to have visuals that you might not include in a paper. But so I think about like, what are the stakeholders, want to know firsthand? And often that's a lot of like really descriptive statistics. And then it's like okay, but how does condition differ by species for this group of trees we've inventoried, right? So then it's the bivariate, like 2 variable analyses. And again, some of this stuff is like, the things that we might look at as a team to kind of see what the data looks like, to make sure the data is clean, right? And to show to a practitioner stakeholder. But like, if we're running, if we're trying to come up with a model of survival results, right? And we're trying to, I don't often like, we collect condition data, but I don't usually, it's condition is sometimes garbage. So we don't often include that data in our regression models. So there's different kind of characteristics of your data that you want to see, that others might want to see, that are certainly true of your data, but aren't necessarily like, as Allyson mentioned, like, what's the research question, right? Like there's a whole lot of things we want to know about our data that aren't the research question, that aren't answering the research question. And some of those things enable us to then proceed with this, just to like verify that the assumptions of non-correlation or independence or whatever we're for statistical analyses we're using. But some of those things are just like interesting for the people who planted all of the trees 5 years ago that I'm now inventorying. Like they want to know all these things.
Mm-hmm. Yeah, no, I think that's good. The guiding light is it relevant to the story, or if it, because you only have so many figures to work with, very cool. So Elise, do you have any more student questions that are, because we were down to like 9 minutes, so.
Yeah, well, I'd like to combine 2 questions that have come in. Data dress up and data distortion. It would be it'd be great to know if you have any thoughts on or examples of either of those that you've seen, and how do we avoid those two things. You know, dress up is probably a little less intense, whereas, you know, we definitely don't want to distort data. So, you know, do you have any examples or tips on how to avoid that?
Oh, go for it. I was typing in the chat, so I'll let you go first. So
Okay. So I think on the distortion angle, and this partially comes from the fact that I do a lot of more social science research, and anytime you're using a Likert scale, right? So that's those like ordinal categories of you know, always to never, or strongly agree to strongly disagree, or something like that, or very important to not at all important, right? Whatever it is, every time you have those like 5 categories like this, I think, and this is something that different people feel different ways about, different statisticians and sociologists, and kind of who you're talking to varies a lot on this perspective here. But a lot of times I dislike it when people take those like 5-point scales and give me an average. Like give me an average number, basically turn strongly disagree into a 1 and strongly agree into a 5, and say the average of my respondents is a 3.5. So they're just over neutral. And I think I always kind of ask the question, I'm like, if you have, and you're like, okay, I don't know what your distribution is, because usually if you're telling me it's a 3.5, you're probably not telling me what your distribution is. But what if you have a population of 10 people who answered that question? 5 of them said strongly agree, and 5 of them said strongly disagree. Is the average, is the mean response, is the median response for that? Let's say there's 11 people and one of them answered a 3, so we can use median. Right? One of them didn't care. Is the average or median of those 11 people a 3, somebody who feels neutral about this issue? No way, right? Like, so that to me is like the textbook worst form of data distortion. Take tree, you know, it can be tree condition, can be kind of the same thing too, right? Is an average of 5 trees that are dead and 5 trees that are in excellent condition 10 trees that are in middling condition? No. Right? So I think like thinking about what the measure of central tendency that you're trying to use means substantively in the context of the distribution of your data, that to me is the #1 faux pas you can make, especially if you're interpreting non-continuous data, like these ordinal categories, and especially if you're like people who interpret social science data do it a lot more, I think, than people who typically have biophysical data. But like those think about those categories, man, and like really think about what the average means, and does the average make sense given the distribution of responses for a particular variable. Like that's and if you're not conveying full information about the distribution, like if you have a bell-shaped distribution and like very few people said disagree and strongly disagree and very few people said strongly agree, then like maybe you can use a central tendency measure like an average there. Like maybe that's not super misleading. But I gotta see, as a reviewer, like I want to see the distribution of responses. And if it's a survey, I want to see them for every single darn question that you're using, because otherwise it's just otherwise you're not telling us the full story there. So that's my high horse about data distortion.
I love distributions too. These are some violin plots that we did to see how people scored likelihood of failure rating. And like you can see here, like here's the average here, but the real story is that you have almost a 4-way split.
Yeah,
people are just so not consistent, you know, as you add different types of information into like a risk assessment, you know.
Yeah.
So this thing's a little busy, but I don't know. I was trying to get away with more figures. My paneling stuff.
Yeah.
Allyson, any well, do you want to do parting shots? Like any wisdom you have in the last 4 minutes that you want to, any take-home points you haven't been able to cover yet?
Sure. Yeah. Again, I think also kind of going back to that distortion, I would bring it back to kind of the idea of whenever possible to essentially like to show as much of your data as possible and as feasible. And sometimes that makes for like a really cluttered graph. or really messy visual. And again, that's where having your supplementary data can be really helpful as well. I think that's can be really important. I think it's also important, like during the graphing process, to kind of back to that distortion versus dress up debate, is to sometimes kind of like step back and sometimes even just to like stop looking at your graphs for a while, have someone else look at them and tell you like how do they interpret, because it's very, our brains like to look for patterns, our brains like to simplify things and jump to assumptions really quickly, and that's why visuals can be really misleading sometimes, even though we don't intend for them, even if we don't intend for them to be, they can be misleading. And there's a lot of great writing on the internet about that, to kind of go into more depth on that subject. But otherwise, parting shots, I think visualizing data is super fun and is it's just another way to communicate via science. And a lot of times I think it's a more efficient way to communicate. So I think it's worth putting a lot of time. I think it's worth putting the time and effort to think really deeply about this subject, because it can be such an effective way to communicate what you've learned.
Okay, and Jess?
Yeah, I think the one thing that we haven't much talked about, and Allyson suggested, like, sketch out your graph first. And so I think, like, we've talked a lot about technology and different forms of technology, but I think one of the most powerful forms, and this sometimes happens even before you've collected your data, is to sketch out how you might, like, what might you want the final figure to look like, right? Like, what's a hypothesis, like, sketch out your hypothesized relationship, right? Oh, okay, we might see that, condition for this type of trees as the box plots way up here, and the conditions for these types of trees is way up here, or survival rates for different trees in different types of neighborhoods or something like that, right? Sketch it out. And then, like, even as you're doing the data analysis, really keep sketching it out. And I've done a lot of, like, included actual sketches, sketch out your theory too, right? One of the things that can often be a really great visualization, not so much of data, is like sketching out conceptual models that are helpful for your paper, or frameworks, right? That, where you have kind of boxes and groups of variables. And I think, there are other ways of conveying, especially when you do kind of qualitative data, right? There are ways you can talk about theming your data and, having kind of spider diagrams or node networks of social network data of who's connected to who and what group and what are they doing, and or mapping, right? Like, there's a lot of different ways of data visualization here that can be really helpful. Yeah, exactly. Like, this is like a good example that Andrew brought up here.
I was going to talk about that one some more.
Like, this is cool, like, because you can kind of see what types of data here are potentially important and for this type of a theory. So there's other things about visualization other than just like the R graphs and the Excel graphs and that type of stuff too. And I think don't forget about some of those things, because sometimes as scientists, we get too sucked into the, like, numbers part of things and forget that there are conceptual ways to talk about the results of our research more qualitatively, visually, I guess is the way I'll put it.
Amazing. You guys were great. You can see the excitement about graphs and figures and tables, which is a daunting subject, but I knew you two would be up for it. So just from your work and what you've been able to put together, and your mastery of Excel. I didn't know that figure came from Excel. That was a little behind the scene, Jess, that I did not know.
And InDesign, man, and don't be afraid of Adobe InDesign, especially if you're at a university. They probably have a free version of it. So.
And PowerPoint also has some cool tools if you don't have exact access to that. So
yeah,
I
PowerPoint
also
is
dropped a link for Inkscape, which is a freeware version of Adobe Illustrator. It's not quite InDesign,
cool.
but it's a great. Inkscape is the tool I use to build this figure that Andrew's showing. It takes a bit to get a hang of, but if you don't have access to Illustrator, Inkscape's a great freeware version to work with if you're inclined to do that kind of work.
Well, very good. Everyone, let's give them a round of applause. with a virtual round of applause. And thank you all for your time this week. We'll see you next week. I believe it is, we talking about reviews next week and dealing with reviewers, maybe. So that would be like Rich Hauer and Gary Valad. And that'll be a very interesting topic because it's about, you know, people punching you in the dark and how to deal with that. So, okay. Well, thanks everyone. Take care. And I will post this video online. So.
Great.
Cool.
Thanks,
Thanks,
Andrew.
everybody.